All right, so we don't have many questions there on the Google Doc. I pretty much finished everything already yesterday. There's only one new question there, but it's more like a clarification. Let me mention that quickly, and then for those of you who are here, you can ask me any questions related to the lecture. All right. The only thing that's on the Google Doc over here is about a typo from the slides. Let me just mention that about the idea, and then I will tell you which slide you should go to. The slide has been fixed already. Okay, so if you go to the weather data class, so this is when we talk about the first design attempt about a remote procedure call, the very first one. And then we said that given that we have this particular class invariance to make sure every time you create a weather data object, you have to make sure the temperature, pressure, and humidity, they must be within the legal limits. So that's the class invariance. And we say that in order to make sure if you first create this particular weather data objects using the constructor make, or whenever you want to change the measure, right? So these are the two use cases for the make, either as a constructor or as a command. You want to make sure the resulting values after assigning T, P, and H, to the corresponding attributes, you want to make sure these attributes values should still be within the legal limits, right? So they are required over here on the slides actually say temperature, pressure, and humidity. You may have found that a little bit weird over here, right? So what I really meant to say here is the T here, and also the P here, and also the H here. So the input argument over here should be legal, okay? So one of your fellow students actually found that. So this is definitely a typo. Okay, so that's about the first one I want to talk about. Let me just show you the slides just to make sure that one has been fixed. If I remember correctly, if you just go to slide number 5. Yeah, slide number 5, and then you can see that correct limits. Okay, this has been fixed already. So if you downloaded the slides before today, earlier this morning, so you may want to re-download the slide. So this the typo is fixed. Okay, other than that, it was okay. All right. So that's about the only question that's new from yesterday about your lecture. All right. All right, so guys, so now I'll open the floor to you completely. Do you have any questions on the fly about the lecture? You're welcome to ask me any questions before week 9. That's also fine. Okay, any questions? But for the project, I would suggest you reserve the question for the project either to my office hour today, which will start at 4 p.m., or we have a dedicated Q&A session for Thursday afternoon. And then there's a Google Doc also for the project Q&A. You can definitely put your question there. Or alternatively, you can always put your question on the forum. Okay, anyway, so I should really dedicate this time for any lecture material related questions, if you have any. Okay, I'll pause here and see if you got any questions. We got quite a small group today, so you can ask any questions you like. Anyone?
Hi, Jackie.
Hi, Robbie. How are you?
Good. I had a question about the state design of pattern.
The state design pattern. Okay, Robbie, give me a moment. Okay. Let me just go to the slide so you can tell me maybe which slide that will also help everybody to benefit from this. The state design pattern, just give me a moment. So let me go to over here. All right. So Robbie, is there a particular slide you want to ask?
Not really.
Sorry, which one?
No, there's not a slide.
Sorry, I couldn't really. So which part of the state design pattern do you have question about?
The social type.
The
type.
Yeah.
He's gonna type it. Yeah.
Oh, sorry. Give me one moment, please. Okay. Excuse me. All right. Okay, Kevin, could you help me again, please?
Yeah, he's going to try and type it out for you.
Sure, no problem. Yeah, I can wait. Yeah. Yeah, I just need to know which slide you're talking about, so it's easier for me to set it up. Well, Robbie, or is it about the iPad notes you're talking about? So is it slides or iPad?
I don't think it's about a specific slide.
Okay. Okay. Well, what's your question there? I'll try.
I guess about the state transition.
The state transition. Okay. What about it? So when you say state transition, for example, you can see here.
Yes.
So are you talking about, for example, this is how we put a state transition, and this is how we make a state transition, for example. This is one case.
Yeah, so would it be wrong if we just like an account in the application class?
You mean the counter over here?
Yeah, so when we want to go to the next state, can we just increment the counter?
Okay, so you're saying that how, okay, you're trying to make some connection to the project, right? To see how we can make a state transition. Is that what you meant?
Kind of.
Kind of, okay. Let me give it a try. Okay, it's kind of a half lecture, half project. Okay, that's fine. All right. Let me try to see this. Okay. Let me just, okay, I kind of get what you're trying to ask. Let me try, okay. But I can add a more follow-up question if you wish. All right. Okay, so let's say, for example, let me just simplify the question a little bit. Okay, so from your project, basically, right? So you basically got setup, select. So that's when you're in a particular state, you can actually simply select, for example, you might select option number 2, right? And then after this, you can, let's say before that, you can say setup. You got setup select, you got select next, for example, and then you say 1. Okay. Of course, this number over here can be any number between 1 and 5, right? So let me just give you one particular example. Okay. Let me be a little bit abstract over here, so I wouldn't actually intervene with your design decision. For example, let's say here, let's say this is our state transition diagram for your particular application, right? Let's say over here, so let's say this is the initial states, I'll say S0, okay? And then let's say we got S1, and also S2, and also S3. Let's say we got 1, 2, 3, 4. We got 4 states in total, okay? So thinking this way, as soon as you launch your software, you're going to be in this particular initial state, S0, right? That's the initial states. And if you say setup next, and then 1, okay, think about what's going to happen over here. What's going to happen is you're going to, the ETF project is going to create an object of type ETF setup next. Okay, so this is the class, right? And under which you actually got the constructor make. And then it's going to be this input over here, I believe is an integer. All right, so far, that's what you will get. And then as soon as you get I over here, basically you're going to over here, so this will be some code you will have to write, right? Let me talk about this a little bit. So basically you will have to somehow update your model over here, right? So you might say, for example, model dot maybe transition, for example. Transition maybe by whatever I position it is. I over here. And then in your model over there, you should really somehow maintain either maybe a table or whatever data structure you think that might be necessary. We talked about the data structure you can use for the state design pattern if you want to use it. So now based on this I over here, first of all, your model should really maintain what the current state is. Okay, so now based on the current states, and also you are given this particular I value, so you have to know, from the current state, you want to make a transition. So what does it really mean? In the current state, you want to jump for 1 and then 2. So that means the resulting state should be S2. So that means the current state should be updated to over here, to S2. Okay, so Robbie, does that kind of address your question about state transition?
No, not really. It is more about like if we had an array of ordered states.
But you want to add a state or?
No, if you had an array, of all the states.
Mm-hmm. Let's say. Okay, let me do that part first. So let's say this is your states array, let's say. And let's say for that, we assume we got 1, 2, 3, and 4, right?
Yeah.
Okay, let me try. Okay, I just need you to help me to really understand you better. So let's say this, we got 1, 2, 3, 4, okay? Assuming that according to the state design pattern, every one of them should have a corresponding class, right? So you can think about it's going to be polymorphic. So maybe for this particular one here, it's going to be simply of type S0. And then the second one is going to be S1. The third one is going to be S2. Okay, and the fourth one, different colors simply mean dynamically they're different types, but statically they should just be a state, right? As we discussed in the lecture, S3. All right, so that's the array. So now, how is this going to help on the state transition? I would say for this particular example specifically, right? So, for example, you can say maybe the current states. I'll just give you some example, right? But this may not solve exactly the general problem, so I'll just give you some idea. Let's say current state is simply of type states. Dynamically, it can be either S0, S1, S2, or S3, okay? Let's have another variable over here. Let's call that maybe currents. Let me just make it a little bit shorter. Maybe current state counter. That one there is more like an index, integer. Okay, let's say, let me just undo a little bit. Okay, let me just get rid of this particular part. Let's say we're still in the initial state. Let's say, let me just get rid of this. All right, let's think about it here. Let's say what we want to do now is we want to say set up next to. All right, so let's say in the acceptance test, this is what you're given, and then accordingly, you're going to create this ETF setup next objects using its constructor. And then the only argument you will take is I, which is of value 2 in this case. So now what we know is this I over here is going to be replaced by 2. All right, and then you can think about inside the implementation of this particular constructor over here, what you would do is you're going to call the relevant routine or updates on the model, right? So let me just call that relevant operation, maybe just transition. You can call it whatever you like, okay? And then we're simply just going to pass just I as argument. But in this case, we know I is simply just 2. So from the model side, currently, because we are not in the initial state, you can think about this. The current state counter is simply just 1. And also the current state is actually simply pointing to S0. So this is before the transition, right? Over here. And now, given that the state is actually something like this, it doesn't really go back, or it doesn't really, well, it might go back, but it doesn't really branch out like this. You can create a state transition table if you wish. I'm gonna skip that part, okay? That's something you can do. I can simply do the following. I can say CS counter is assigned to, because I know I need to move forward for 2. if you want to move backward for 2, you just do the opposite operation. Would be CS counter, let's say plus, right? Since now we got 2 over here, plus 2. So now this will change this to be 3. And now, how should we reassign the current states? So now the current state should be reassigned as follows. You should say current states. Now is assigned to, and then the states. So now the states array, and now whatever CS counter is right now. Right, we know the counter value over here is actually 2. So that means it is now going to point to, so it's going to be plus 2. So that'd be 3. Sorry, I said something wrong here. Because after adding 2, its now value is going to be 3. So that means this will be 3. So now that means current state is now going to point to this particular states. So corresponding to S2 over here. So Abby, does it help?
So would that be correct even though we don't look it up in the table?
Can you say it again? I don't quite follow you.
Just saying, would that be correct even though you don't look it up in the table?
So here I'm actually omitting the part about updating the table. So whenever you want to do the state design pattern, you should really have a maybe have a transition table like what we said in the class, right? So over here, I'm just trying to make the case very simplified. Just update the counter, the index. But exactly how you update the index, that's something you will have to do. So you will need a transition table like this, basically.
Okay.
And then you want to say, for example, let's say this. If currently you are simply 1 over here, let's say your state number 1, and then depending on, well, also depends on how you exactly define the transition. The transition could be, since now I'm taking a transition that will go bring me forward for 2. In that case, what should be the corresponding states? So you can look up the table. Right?
Okay, so we got to use the table. We can increment the counter.
Yes, I would say whether to use the counter or use the table, I'll leave that for you to decide. Because if you simply just use the counter, right? I would say if you simply just use a counter over here, you're assuming that your state diagram simply just looks like this, right? You can only have like almost like a linear fashion of the states. On the other hand, if you have, for example, I'll show it to you. If your state diagram looks something like this, because everybody can be different, but if you look at your state diagram from the very beginning of the lecture, you can see this one is not linear, right? It's simply you can jump, you can go all the way to another one and then come back. So this one definitely has a very different look from this particular state diagram over here. So I would say if you believe for your application you can simply use a CS counter to keep track of the states, in that case maybe you don't need a table, but maybe you need it. So that's something you have to judge.
Okay.
But the principle about having a polymorphic array, and also once you get the index, the updated index over here from the state transition, after that, you can simply use that to really get access to that particular state objects dynamically. That principle remains the same.
Okay.
All right.
Thank you.
Good. All right. All right, so that's more about the state pattern, a little bit relevant to your projects, but that's okay. Anyway, okay, any more questions? Anyone? All right, I'll pause a little bit longer. A question from Nina. Is it still considered a state design pattern if you don't use the transition table? I would say it kind of depends on exactly what you mean. So I can tell you this. you definitely have to do state transition, that's for sure. Exactly how you do the transition, how you actually do the transition, that may be up to your implementation. I'm saying in general, you need a table. But if you believe for your particular case, if you to do state transition, you don't need a table, you might be okay, right? Good, all right. Yeah, so one thing you can definitely think about is while we're learning more and more patterns, I think that we just got one more pattern to learn for this course. We got, so including the lecture that's gonna start tomorrow, series number 10, where we talk about the composite design pattern. And then starting from next Wednesday, we'll learn about the final design pattern called visitor. So for all the patterns you use in the, you learn about in the course, I would say for your projects, for phase number 1, you don't necessarily have to really implement a perfect design, since we don't really check it for phase 1. Only in phase 2, you will be required to submit maybe some design diagram or design decision. In that case, you still have time to maybe refactor your design if you wish. But anyway, it's really definitely worth thinking about which pattern might be applicable to your design. All right, still week 9. I think yesterday we talked quite a bit about the election series number 9 already. So maybe everybody already got their question answered. Anyone?
Question.
Jackie,
Robbie, yes.
in the week 9,
Week 9, yes.
is it the procedure librarian I've already defined?
Yes. Okay. So Robbie's question was, is the procedure clause already defined in IFO? Yes. Okay. Let me. Okay. Give me one moment. Give me. Let me get there first. So Robbie, you're basically talking about this procedure over here, right? Good. All right. So yes, indeed. So this procedure clause, yes, it is actually already defined as a library class in IFO. So in case you're asked about any questions in the exam or in the quiz, you will, let me put it this way. If the question is really about the usage that we talk about in the lecture slide, in that case, you wouldn't be given any extra explanation. However, if you're supposed to use the procedure in a way that's kind of indirect, implicit in the slides, in that case, we'll definitely give you the complete API for the procedure. Okay. Again, you don't need to memorize exactly how the syntax should be, but just need to understand what's going on over here. Okay.
Okay, and then continuing is a plain line 1 the arrow. I don't get the
Line 9?
no line 1.
Line 1 over here. Okay. Line 1 over here. Okay. Give me a moment. Okay. Line 1 over there. So we talk about event-driven design, right? Line 1 over there is not specifically about event-driven design, just about using generic classes. Let's just go over that. So class, and then we have events. Okay, and then we want to say event class is a generic. So you simply give a generic parameter. Typically, we say G, we say H, or I, right? But now this time we simply just give a name that does not exist as a class. We just call it arguments. And then dash greater than, also we spoke about it also in the lecture or maybe in the previous Q&A. And over here, okay, let me explain that. Okay. Okay, let me just do one more. Okay, I can say over here. Okay, over here we got actions, which is a linked list of each element there is a procedure. And then the procedure is going to take whatever arguments you instantiate that to be. Okay, let me just take this one for example. Okay. Okay, let me annotate the relevant usage over here, and then we'll speak about how you can use it, and then you'll see. All right, so over here, so this argument here is the name of the parameter. Oh, actually, yeah, let me just, okay. This is the name of type parameter. And over here, you can see argument over here is simply a usage of the parameter. So this is a use of the parameter. Okay, and then this part over here, when you say dash greater than, so this is called constraint genericity. We also got similar syntax in Java. For those of you who actually use this syntax, I'm not sure if you do, but if in Java, you can say, for example, class events, and then over here, you can say maybe some generic parameter h, and then you will say extends. Some known class, for example, tuple. I'll just say, for example. So that's what you do in Java. So you simply use a keyword extends. You can think about this one here is this, the same as this one here. Meaning-wise, they're the same. All right. Okay, so that's about. We are saying that every instantiation of the arguments into another type, the type must be a descendant class of tuple, including tuple itself. Okay. So now let's see how we can do it. Okay. So now, for example, how you can use it. Okay. Let's talk about the use of the generic class. So here you can say maybe change on temperature. So we want to declare one event. So now you're going to say of type. So now I'm going to say events. Whenever I want to use the generic class to declare a type, I need to instantiate the arguments over here. But now, can I simply just use integer? That's a question, right? The answer is I cannot, because integer is not a descendant class of tuple. That's what constraint genericity really means. You must pass a type that actually inherits from tuple. Okay, so this is not good because int is not a descendant class. Descendants of tuple. That was specified exactly over here. All right. So what can be valid? Okay, so we know that this is not valid. So what can be valid? So let's try this. If I say change on temperature, in that case, I will still put the events. And as you can see from your slides, let me just show you here, and I'll write it down. Okay. You can see this is how we define the class. And then if you go further, you can see the parameter will simply say the tuple. And for the tuple, it contains only one argument called real, right? Only one element in the tuple. Okay. Over here, I will simply say tuple. And then I just running out of space, but I can say real. So you can think about this, this part over here, tuple of real. So this is actually just a type. So this type over here, for sure, is a descendant of tuple. Okay, Robbie, does that answer your question?
Yes, thank you.
No problem. So I think, Robbie, so one thing to note, okay, in case you find this applicable or interesting, okay, for yourself. So the reason that we only put tuple of a single real number, so this is because for the update operation that we want to store for delayed execution, for example, you can see, so now for the temperature, we basically want to, okay, let me just show you here. Let me go to current conditions. The update temperature is really the function or the commands whose pointer we want to store in the events. So now here you can see this is a command that takes only one single argument. So this is why we simply put real over here. In case if the update operation takes more than one arguments, in that case the tuple will just take maybe real followed by a string followed by integer, whatever, right? That's necessary. So this is why we say that you can instantiate the parameter type over here, arguments, by anything as long as it's a descendant of tuple, meaning that it's a tuple taking an arbitrary number of types as the in different positions. All right. So Robbie, does it make sense?
Yes.
All right, very good. All right. All right, any more questions? So Amir, you got any more questions? How about Asma? Are you okay? Oh, I see. Okay, no worries, no worries. But I do appreciate you coming. So Asma, how are we doing? You okay?
Professor?
Yes, go
I
ahead.
actually had a question about the quiz for the state pattern.
The quiz for the state pattern. Okay, what about it?
Yeah, I think it was the questions we were looking at the current states. I got a little confused because of that. I thought we were supposed to point out all the transition states, but I guess we're only pointing out the final one.
Oh, okay. I might know what you mean. Okay, let me take a look. Yeah. Let me just get to that part there. Okay, give me one moment. Yeah. Yeah, let me just retrieve it. So it should be quiz number 8. And then let me get to the question. Okay, so okay, I'm almost there. So Asma, is that the one you're talking about?
Yes. So
okay, sure.
I think we did like 3 transitions in this
We
one.
did yeah, so let me talk about it. Just give me one moment. Okay. Yeah. Okay, let me up to this part. Okay, once I explain this part, everything else should be easier to understand. Okay. Yeah, so you want to understand just one critical line, what that one is supposed to do. Okay. Okay, so guys, this is from quiz number 8 about a state descent pattern. Okay. Yeah. Okay, over here. All right, so over here, okay, let's take a look at this particular one. Okay, first of all, you can see that the current states over here, as we discussed in the lecture, its type is simply just a single state. It's not really like a multiple state, just a single one. And then we're saying that the current state is assigned to something on the right-hand side. So that means for this to be valid, the right-hand side must be only a single state, right? It cannot be multiple states. So let's think about what's happening over here, right? Try to break it down in this way. When you say app, so you can think about the app is the application objects we're creating over here, right? And then app.states. So states is really referring to this particular array over here. Let me just highlight it. You can think about the states over here is simply this particular array over here. And then you can see the square brackets notation we are using. So that means inside this pair of square brackets over here, we need to pass a single integer as the index. So let's see what the integer is. So what's going to happen over here is, let's just try to do one by one. We are basically saying app.transition.item. Think about what's happening over here is when you say app.transition, and then transition is really referring to this particular two-dimensional table over here, and then you actually want to give two integers, right? It should be both the row number and the column number. So now let's look at this. So you got to break it down, of course. So what's going to happen, you can try to look at it more closely on your screen. So this part over here in the pink, so this is basically the first number. And this part over here is the second number. So do you follow so far?
I do, yes.
Okay, very good. Okay, and then let's take a look at another one. Okay, so now what we want to figure out is the first number. So for the first number here is basically another inquiry to the state transition. You can think, let me draw this way. You can see this part over here is basically like that, right? It's going to be this transition here. And that transition there is going to take argument number 1 and also argument number 2. Okay, and then finally, okay, you can see that's kind of like a detour. We just basically just keep calling the transition. Okay, and then let me use one more color. Okay, for the green, you can see now we also got after transition and then 1 and then 3. 1 and then 3. Okay, so now let's so that means before you can figure out the pink one, before you can figure out this particular answer over here, you will have to figure out both this and this. And before you can figure out this, you have to figure out this and this, basically. Okay. So now, since we know this and this, they are simply just single numbers. So we can definitely look up the table. Okay, let's try to see. So now for the green one, when we go to transition table and we get 1 and 3. So that means we get 1 and 3. So that's going to give us this particular number 2. Okay. So that means over here, this particular transition over here is going to give us actually this number 2, right? This is going to give us 2. Okay, so this part here is going to give us 2. And now we actually got the green one and also we got the 2 here. Let me just use the orange. So we also got 2 over here. So that means we can look up to the table 2 and also 2, right? So 2 and 2. So 2 and 2 is going to give us 1. So that means the pink part. So that means this part over here, right, where we simply look up, let me just draw a little bit better. So this part over here, where we simply look up the 2 and 2 is going to give us 1, okay? Let's see if that's the case. Yep, 2 and 2, yeah, it's going to give us 1. It's going to give us 1. Let me just write it down. So that's going to be 1. All right, so finally, you can see we got this 1 here. We got this 2 over here. So 1 and 2, what should that be? So 1 and 2. So 1 and 2 is going to give us 5. Okay, so the final number we will get is actually 5. This one here. So the final one we're going to get is simply just 5. Yeah, it looks a little bit complicated when you try to trace it, but I think once you think in your mind, it's not too bad, right? So basically it's 5. So that tells us eventually it would be as if we simply say current states is simply assigned to app.states and then simply index 5. That's the final answer. And now we know that 5 is actually referring to confirmation. So that means after this, dynamic type for the current state will be confirmation. And then for your quiz question over there, you're basically just trying to see what it is an instance of, right? For example, the 2 answer you will get is, if you try, for example, attached, and then if you simply just give itself confirmation, and then you say current states. So this one should be true, right? It should be its own descending class. And then when you try another one, if you try another one that will be true, is attached. And then if you simply put the states over here, and this is current states. So this will also be true. Think about this. If you were to do the corresponding cast, can you actually cast the current states, which is statically a states, into the states? It should be okay, right? Well, you think about the dynamic type simply confirmation, can you simply upcast to the states? So that will be okay as well, right? So that's why these two expressions are simply just true. But all the others are false. So does it help?
Yes, it clears it up. Thank you, Professor.
Okay, no problem. No problem. Good. All right, so that's a question from Asma. Yeah, so I think, yeah, you talk about the time for quiz number 8. Yeah, I would say, I think that you would definitely find maybe some quizzes so far, some quiz, maybe you find the time is actually maybe more than enough. Maybe some quizzes, it can be a little bit challenging. I think maybe that's somehow the sum may not be exactly equally distributed for each quiz. Yeah, if many of you reflect to me that maybe a particular quiz, maybe you don't think time is enough, I'll try to see if I can adjust for the next quiz. Yeah. All right, any more questions?
Thank you for that question. I will.
You want to ask this particular question, Robbie?
Yes, I
yeah. Yeah, give me one moment. Yeah, let me retrieve that question there. Give me one moment. That one is about a template design pattern. Okay, let me get it. Something about the temp. Okay, I see. Okay. Let me now get it. You know what? Let me copy that. So that should be either true or false, right? Okay. Okay, let me move that to my iPad and I'll speak about it. Yeah, the font size may be a little bit small, but you guys also got access to your quiz, so you can see what I'm trying to do. Okay, you know what? So, okay, sorry, let me do a little bit better. Yeah, let me just try one more time. Okay, I think that may be a little bit better. Yeah, bear with me for the font size. I think that's kind of the largest one I can do. All right, okay. So that's about the template design pattern, okay? The template design pattern. Let's talk about one by one. Okay, so now the first one. In the state class, okay, first of all, let's remember what it is, the template design pattern is, okay, quickly. So remember in the state class, which is deferred, I'll just make for one example. Let's say, for example, confirmation is one of the, that you choose that as a representative. So this will be confirmation, okay? And then the template itself is the execute. So this will be the structure of the templates. Where you actually got some control structure to combine all the components together. And then all the rest of the deferred routine, they are the components. For example, you got display, and also you got the read and etc. Okay, so these are the components of the template. So think about the actual template actually will combine all these different components in a way, following some control structure, basically, okay? And then one more thing to say, and then we look at each option together. And this one here, execute, we also discussed this in a previous Q&A. So for your particular implementation, if you decide maybe in a particular class, you want to simply redefine execute, it would be okay. However, I would say that's not very typical. So the standard case would be the execute would just be reused verbatim by every descending class of the states, typically, right? That's why it's called a template. It should be a common template for all the states. And then, so typically what you have to do in the effective class would be you have to implement every component specific to that particular class. So here, you want to say, what does it really mean to display if I'm in the confirmation states? And what does it really mean if I want to read some inputs from the user in the confirmation state, right? So that's a template design pattern. So now, having this in mind, let's now take a look, okay? So now first one, in the state class, the structure of a pattern, which is the execute, right, is implemented as an effective routine. So this part here is wrong because that one, oh, sorry. This one is right. Beg your pardon, let me take it back, okay? It's implemented as an efficient routine. So this is actually right because effective is definitely, execute is definitely effective, okay? So now referencing all other deferred routines corresponding to components of the pattern. So this is actually true. Okay, so now, any question about the first option? You know what, let me open the chat over here, so just in case. Okay, that's the first one. Okay, let's see the second one. The second one, in each of the effective child classes of the states, so for example, let's say the confirmation, right? It is expected that the inherent execute pattern is redefined to suit that particular state's need. So I would say it's not a standard, right? So this should be false. So when we talk about the template design pattern, we are really talking about a standard. So when you say it is expected, I would say it will only be in the exceptional cases you want to redefine. So it's not expected, all right? So this should be false for the second one. All right, so the first one is true. Okay, let me just put a little bit better. So the first one is actually true, and the second one is false. Okay, let's move on. In the state class, components of a pattern are implemented as effective routines. So up to here, you already know it's false, right? When we talk about components, you talk about display and also read. So they are not effective at all in the state class. They are simply deferred. So you can see the effective part is simply just false, right? Because you're only, you're not really expecting to reuse the display and the read in all the descending classes for the state class. No, that's not the case. So they're supposed to be effective. They're supposed to be effective, and then you're supposed to effect them. Sorry, they're supposed to be deferred, and then in each of the descending classes, you're going to implement them. Okay, that's why it is false. All right, hopefully so far so good, right? I don't see any follow-up question on the chat. All right, let's go on to the next one. In the state class, components of a pattern are declared as deferred routines, okay? Expected to be implemented in all the effective descending classes, right? That's exactly the standard. So this will be true. All right, next one. In the state class, the structure of a pattern, so we talk about execute over here, is declared as a deferred routine, right? As soon as you see this definitely is not deferred, right? Expected to be implementing all the descending class. No, you're supposed to reuse it. So that's why it should be effective at this level over here. So this one should be false. Okay, the final one. In each of the effective child classes of the state, for example, confirmation, it is expected that the inherited routines, for example, display, right? You can think about display like a components. corresponding to the components of the pattern are not redefined in order to maximize reusability. So this one here, basically, since we know this display over here is deferred, so when it is actually inherited to the confirmation class, you must implement it. So that's why you will see display plus over here, right? So now over here, when you say are not redefined, so this one is simply just false because you're supposed to implement it. All right, so that should be false. All right, Robbie, so is that okay?
Yes.
Okay, so Robbie, which one were you actually more concerned about originally? I kind of explained every one of them, but which one were you? Let's say number 1, number 2, number 3, number 4, number 5, and number 6. Which one were you more concerned about originally?
Number 5 and 6.
Number 5 and 6, yeah. So I think for number 5 and 6, you can see number 5 here is about the structure of the pattern. And that one is really to be executed. That's supposed to be implemented, right? So as soon as you see it should be deferred, that's already false.
Okay.
Good. So I think for number 6, it might take a little bit of reading over here. Okay, but I would say when you do the true and false question over there, I would say as soon as you read anything that's actually already identified as false, the whole thing should be false. So in order for a statement to be true, every part of it should be true. So now for number 6 over here, what's really wrong about it is when you say, so each effective child classes, the inherited routines display corresponding to components of the pattern. So far it's okay, nothing wrong. However, as soon as you say not redefined, so this is really the problem over here. Because the reason that you want to inherit the display into this class over here is not for reusability. When you say you want to do, have reusability, so that means you want to reuse the code. But this is only just deferred. How can you reuse the code? So that's why this is simply just wrong. Okay, that's for number 6. All right. All right. Any more questions? Anybody? Wei Ming, you okay? Oh. And Si Wei, you're okay? If you guys are still here. All right, very good. So Sabrina, you okay? No problem, no problem. And Nina. Okay, good. You know, we got a small group, so I can call everybody. So Manur, you okay? All right, very good. Jia Hao, you okay? Oh, okay, you're good. Okay, very good. Yeah. So Asma, any more questions? You're fine.
I'm good, Professor. Thank you.
Okay, thank you. No problem. Okay, Amir. Yeah. So I think you can still ask me questions tomorrow if you wish. Don't worry. You know. Yeah. So guys, if you're still a little bit behind for the lectures, I would say try to catch up as much as you can, and then I think eventually we'll get to your exam. But fortunately, your exam is about 12 days after the last class. It's on the December 20th. In which case, we can definitely schedule some review sessions, so you can definitely ask me more questions around that time. Okay. But I do appreciate your coming. So I think even unprepared, that's okay. Just listen to your fellow student question also can be beneficial. All right. Yeah, I'll pause for maybe a few more, maybe one more moments, and then to see if you got any more questions. Right. I still got office hour 4 p.m. You're also welcome to come. All right, guys. Do you want a tip for quiz number 9? Any objection if I give you some tip? All right, yeah. Okay. So I presume no more lecture question, right? All right, okay. Let me give you a tip. Okay, I would say for this week, don't be too concerned about not really understanding the syntax for agents for this week. It's okay. I know that it's only your first week understanding the lecture. I might put off the question maybe to the exam. So we also got a review session to help you. So don't be stressed over too much about the syntax. I would say this week, you before you take the quiz, you want to be very clear about. Okay, let's say this. We talk about 3 designs in this lecture, right? So whenever I say design number 1, you will know I'm talking about a remote procedure design. Whenever I talk about design number 2, you will know I'm talking about the observer design pattern. And whenever I talk about design number 3, you will know that I'm talking about event-driven design. So this week, quiz tend to be more about checking your understanding. May not be so much about coding, okay? So, but I would say for the last few parts of the lecture, I would say just make sure you understand the big picture about how classes work together. And then, let me just summarize to you. For example, you can take notes later from the recording. What's really to do with the design number 1? So the design number 1 is really important to understand that the clients is very proactive about updating themselves to the latest change, right? So every time when you call the display, they always do the update first. So that's why we say the clients are very proactive. Whereas the subjects, in some way, the opposite is actually very passive, because every time once they set the measurements, they don't really notify anybody, right? So that's about design number 1. And we know that how wasteful of resources it can be. Okay, that's about design number 1. So what about design number 2? So it's the observer pattern. So now for the observer pattern, you should really understand that the clients right now becomes passive, which means you only try to update the clients on demand. So to really achieve this, the subject is now very proactive about any changes they make, i.e., whenever there's a change on the subject side, you will have to notify all the observers that are subscribed to this particular subjects. Okay. Okay. Before I move on to the 3rd design, let me read the question from Wei Ming. How to remember the design number 3? The code is a little complex. So I would say, okay, that's a good question. Let me just mention about this particular part. You definitely don't want to memorize the code, right? That's not because, well, in some ways, it's an open book quiz. So given that any questions related to design number 1, design number 2, you can answer them hopefully with a shorter amount of time. So you can give yourself more time to think about design number 3 if needed during the quiz. I would say the main thing you want to know for design number 3 conceptually really is this particular diagram. Let's now go to here, event-driven design. All right. So guys, I cannot emphasize this enough, right? So whenever you want to review design number 3 about event-driven design, right? So now, what should you know about this design conceptually? Okay. First of all, thinking this way, we got 3 parties over here. We got the subjects, you got multiple subjects over here, and also you got maybe multiple events, but I'm just showing you one event over here. Also, you got multiple applications, right? So we got these 3 parts over here. And now, think about how it works at the runtime, okay? Let me say this, let me ask you the following. If I say, whenever there is an update on the subject side, it is going to notify all the subscribed applications. Is the statement I just made true or false? Let me repeat my statements, okay? Whenever there is an update from the subjects, it always notifies all the subscribed applications. Is this statement true or false? I see true. Okay, anybody? I see true. Okay, I'll wait for maybe a few more responses, and then before I tell you. Anyone? Yeah, I guess maybe some of you haven't really reached that part. Maybe that's why you don't think yourself are ready, okay? All right, for those of you, I do appreciate Wei Mi, Amir, and Robbie. I appreciate your answer, but the statement I just said is false, all right? Let me repeat, okay? I said whenever there is a change on the subject side, it is going to notify all the subscribed applications about the change. That's not the case. What I just described is the observer design pattern. It's not event-driven design. Think about the essence about the event-driven design is, so whenever there's a change from the subject side, what you would do is you're going to publish, well, just going to publish the change to the relevant events. You publish to the events, not to this, not to the application. There is no direct relationship between the subjects and the observer in the case of the event-driven design. So once you publish the change to the relevant events, the event is going to execute all the store actions. So those action pointers are stored over there for delayed execution, and you're gonna execute those actions one by one. So that's how the event-driven design works, right? I think that's the most important concept to get for the event-driven design. Okay, and then how do we store the function pointers for delayed execution? The way you do it in Java versus the way you do in IFO, they are different, right? But fundamentally speaking, they're really doing the same thing, just to store the pointer. All right. All right. So I think for this week's quiz, I think you don't have to stress over too much about the code, but you definitely have to understand. For example, for the event-driven design, design number 3, you want to know how really things work, right? Number 1, whenever you want to subscribe an application, you don't subscribe the application to any of the subjects. You only subscribe their update operation pointers into the relevant events. Number 1. Symmetrically, if there's any change on the server, you're going to publish just the change on the event so that the event can really call the delay, the function pointers for delay execution from all the applications, right? All right. So the main tip is you have to basically understand conceptually how to combine, how to compare all the 3 designs. I think that's important because all the 3 designs are really meant to solve a similar problem for distributed client supplier, right? The client server application, right? You should know the pros and cons for each one of them as well. All right, I hope that's enough tip for you. Quite a bit of long discussion. All right, good. Yeah, for those of you who came here, I hope that can help you, right? But of course, your fellow student who listen to the recording, if they bother, that will help them as well. Okay, guys, any more questions? All right, okay, final reminder. So for this week's quiz, I would say this week's quiz tend to be, maybe the number of questions tend to be more. However, each question is brief. So I would say try to really make sure you really understand each design that we talk about, all the 3 designs, about its pros and cons, and also really how things work. But since I can see many of you actually attended the Q&A both yesterday and today, just make sure you review the important bits, then you should be all right. All right? Okay, so I'm going to stop over here. And then if you got any further questions, just get in touch with me or just drop by 4 p.m. to the office hour. All right? Okay, guys, take care. I'll see you later.